This is part 9 in our series of lectures on section 1.6. In this lecture, we're going to look at this piecewise defined function, and we're going to prove that its limiting value as x goes to 7 is not equal to 6. So this is an exercise in dealing with working definitions. And so in order to do it, what I want you to do is to prove that the negation of the statement that the limit of f of x equals 6 is true. So the first step is to write down what it says in symbols. And so if you began on a piece of scrap paper by writing down what it means to say that the limit of this function is equal to 6, and then just simply take a useful denial of that, that's what I'm looking for in this first part. But when you do that, don't worry so much about filling in the actual values of the function. Just simply use the generic notation f of x, but do fill in the correct a value and L value into your statement. Okay, so go ahead, put your video on pause, and write down what this says in symbols, but it's okay to just use the letter f when you're referring to the function. Okay, so you'll recall to say that the limit is equal to 6 says that for every epsilon bigger than 0, there exists a delta bigger than 0, such that for every real number x, if the absolute value of x minus 7 lies between 0 and delta, then the absolute value of f of x minus 6 is less than epsilon. So a useful denial of that is there exists a positive real number epsilon such that for every positive real number delta, there exists a real number x such that absolute value of that x minus 7 lies between 0 and delta, and the absolute value of f of x minus 6 is bigger than or equal to epsilon. Okay, so this is the Pn not Q part of the useful denial of P implies Q. So what's really involved in proving a statement like this is true? So here I've drawn the picture of the function for you, and if you read from left to right, you'll see that the very first step involves you making a choice as to some special epsilon. You have to choose an epsilon such that the rest of the statement works. So you have to figure out what epsilon will do this job for you. And if you just look right at the end as to what you need this epsilon to do for you, regardless of where this x comes from or the delta comes from, you're going to need f of x minus 6 in absolute value to be bigger than epsilon. So there are only two f of x values. There's 6 and there's 9. And so either f of x minus 6 is 0 in case f of x is 6, or it's f of x is 9, in which case this would be 3. In other words, if x is over here somewhere, if x is to the right of 7, then f of x will be 9, and this will actually be 3. So that sort of suggests to you how you should be choosing your epsilon. I think if you choose your epsilon to be anything 3 or less, you know, it's got to be positive, but anything between 0 and 3 will certainly work. So I would just simply say choose epsilon to be 3. Now in the next step, someone is going to give you a challenge of some positive number delta. So they next give you some positive number delta, and you next have to explain how you're going to choose a real number x. And what is the property of that x? Well, that x has to be within delta units of the number 7, and this has to happen. So we already know that if our x is chosen to the right of 7, then this will definitely happen. So this condition here, you see, you have no control over the delta that they give you. So essentially what's happening is you're being given some delta. So the delta is basically giving you a little interval centered at about x equal to 7. So delta is essentially this radius here. And so what you want to know is, given that they've given you this delta, so they've given you this little interval, centered about 7, can you choose an x in that interval with the property that f of x minus 6 is bigger than epsilon? And the answer is sure. All you got to do is pick your x over on this side rather than on this side, because if you pick your x over here, you're going to have f of x equal to 9. So you would want to pick your x in here. And so how should you choose it? That's the question. So start again. You start off by saying choose epsilon equal to 3. Then you say let delta be a given positive number. And now you've got to choose an x. The x has to lie somewhere in this interval. And you've decided that you really want to choose it in the right half of that interval. So can you think of a way of expressing what x should be if it doesn't go as far as 7 plus delta, but it's still on the right half of that interval? Can you think of a way of doing that? So that's what you have to figure out. What's a good way of expressing that? And once you have that, I think the rest of the proof is easy, because you'll automatically have this and you'll automatically have this. So let me leave the rest for you to do. Put your video on pause. See if you can write up the proof of this statement. As usual, reading from left to right. When you see that there exist signs, that means you have to choose something. And when you see the for every sign, that means you have to say let, and that means someone is essentially giving you that named variable, and you have to deal with it somehow. Okay, so put your video on pause and see if you can write up the proof, and we'll compare our answers in a few moments. Well, as you can see, my proof is very short, and so follow along. Read this from left to right and see if I'm doing what I said I'm supposed to be doing. So the first sentence is, choose epsilon, and I have to explain how I'm going to choose it. So I say, choose epsilon equal to 3. Now I come here, and so I say, let delta be a positive real number. Now I have to explain how to choose my x. And you remember what the issue was? The issue was I had to choose my x somehow in that interval determined by this delta. So the x has to be in here, and we decided that it's best if it's in the right half, because we want to make sure that the f of x minus 6 is at least epsilon. So the x has to be here, so we have to pick our x there. And so what did I do? I said choose x equal to 7 plus delta over 2. 7 plus delta over 2 is guaranteed to be a little bit to the right of 7, but not as far as the end of the interval. Now, what do I do with that? Well, now that I've chosen my x, I have to verify that the rest of it works. So I have to verify that the absolute value of x minus 7 is between 0 and delta. So that I do that here. Then, absolute x minus 7 is equal to delta over 2, which is indeed smaller than delta. I probably should have also observed that that quantity is positive. Okay, I only get 99% for my proof this time. And finally, I have to verify that this also happens. And so, and absolute f of x minus 6 is what? Well, f of x, since x is more than 7, the f of x must be 9. 9 minus 6 is 3, which is indeed bigger than or equal to epsilon. And so that completes the proof.